Hi everyone, I'm going to explain how I solved the optimization problem here, and by using the KKT method. First step is to set the Lagrangian with reaction constraint here and this one. Next, we need to construct the KKT conditions. The first two action here is the derivative of the partial effect of the x with respect to x and y here. We use them to get the stationary point. Then we need to judge each station point whether they are the maximizer, minimizer, or set point, maybe. Okay. The next three is the constraint provided by the problem, and the last four is the definition of the KKT condition. Each multiplier should be larger than or equal to 0, and each multiplier times their constraint should be equal to 0. And we also have provided the gradients of G and Hessian matrix here. Okay, next. Next, we need to solve it. The first case is set all multipliers equal to 0. So the station point here is 0, 0 here. It says for all constraints here. So we calculate the Hessian matrix to find whether it is a positive definite matrix or a negative definite matrix, or it's indefinite. So by calculating the Hessian matrix, we find this matrix is a positive definite matrix because all the leading principal minus of it are positive. So according to the definition, we find that xy equal to 0, 0 should be a local minimizer, and it's a local minimum. Next, we set one of the multipliers larger than 0. First is the lambda 1. We have three cases here, and we need to calculate it one by one. First is to calculate xy equals 1, 0, satisfying all constraints here. But here, we need to calculate the border Hessian matrix to judge the Hessian matrix, whether the Hessian matrix is a positive definite matrix or a negative definite matrix. Here, we find that the determinant of the border Hessian matrix is 10 larger than 0, and it has the same sign as the -1n here. So it's so we find that if it's a Hessian matrix is a negative n matrix. According to the definition, we find that xy equals 1, 0 is the local maximizer here, and we get the local maximum. Next, we repeat all the steps before, and since the determinant of the border Hessian matrix is -5, it's smaller than 0, it has the same sign of the -1 power k, so we get the positive definite matrix here. So it's a local minimizer and a local minimum. And next, we repeat again, get a local minimizer again. And this is a case 3. We set lambda 2 is larger than 0. It is similar to the we have done before. And one difference is that here, case 3.1, the station point that does not satisfy the first constraint, so it cannot be a station point which we need. And the next is we repeat again, get the local minimizer still. Case 4 is similar to the case 3. I just show it. Okay, now case 5 set two multipliers larger than 0. But here, since n equals 2 and k equals 2, we find that we have no determinant to calculate here. So the station point here is inconclusive. Be similar to case 6, be similar to case 7. And case 8, we set all the multipliers as larger than 0. But here, we can have no solution because if we want to satisfy all the three constraints, we have to make the intersect at one unique point. So we cannot do this by decimals here. And then, so the summary, we have 9 cases here, and my conclusion is that the solution of the global optimization is 1.0, and the maximum is 5. That's all. Thank you.